Hello. Another episode of Automat where we work on assembly system. Let me fire up cursor. Okay, during the last stream I said we are going to use Composer. I didn't have the opportunity to use it last stream. It would mess up too many things. But today, this is exactly what we are going to do. I'm writing in a very specific way, which makes it easier for the AI to work with our code. So, Automat, Composer, settings. And I remember there was this feature to enable YOLO mode. I don't see it now. Anyway, we are working mostly on the Linux assembly test. So we are running this composer here in agent mode. Sorry, I think that was my PC. And I would like to move this panel to the left. Can I do that? Okay, maybe I need to open those settings.
Marek Kowalski says,
Hello.
Hey. They are changing stuff, they are removing things and I don't like it. I really preferred when cursor was... It used to have more options. Okay, let's write some prompts. So I know what this file does, I'm just telling the model to read this file so that it builds a linguistic kind of understanding of what's inside. It's going to essentially, we can open this as an editor. Nice. Okay. So the thing with Composer is that in addition to generating code, it can also perform actions. So here, I told it to execute a command, and it says that, hey, I want to run this command in a terminal. I say OK, and it runs it, and it gets the response. Perfect. Now, the thing, we are going to ask the cursor to write more test cases for us, because it can do this stuff manually. We just have to approve of the command execution. We can... I really like this YOLO mode. I regret it's no longer here. We can ask it to run this in a loop, so that it will run the tests will fail, but it will get the error message. So there is no need for us to copy and paste between terminal and chat. So I'm asking, could you write a test case that would exercise a sequence of instructions? Okay, I am starting slow because I don't want to start with something overly difficult. So because it's working in this agent mode, it can search the code base, so it automatically picks the sources, the context that it needs, and it suggests completion. Okay, let's say accept and run this command. We can essentially leave it there. It should kind of do the work for us. I think a large part of this could be actually extracted. Those condition variables, like the waiting for the assembly, for the machine code to finish. This part we could probably factor out. Okay, let's accept all of the changes first and then run the command. And I gave it a very, very simple task. Okay, so what is it doing? Okay, it actually created a test class. This is a good idea. The first test still passes nicely. I think it's having issues with building the sequence of instructions. Because the way we do this stuff here, we should connect them using our connections, and I see it's not doing that. We probably didn't give it any example, so let me accept this. And I will stop generation. So I will do cancel here. Cool. So the first test passes, but we are logging just a ton of stuff. I think we are logging way too much stuff. We don't need it. I will introduce so one thing I would like, this is a common pattern in test cases, is to, in each test case, to have a list of events that are happening. So as the test executes, we are appending new events to this list. At the end, we can verify that the events are correct. We can ignore some events which we don't care about, like if there is something flaky. But we can verify that the key things that we wanted to happen during test execution happened. Okay, let's ask it to do something else. So we'll do those instruction thingies, but let's ask it to so temporarily we have to ignore the failing test. And I should probably also say that this failing test case should be improved, sorry, should be ignored. Okay, this controller, also this is going to be the same for each test case. So here we can have setup. I think this should be done in the setup, this controller. Okay, I like this naming. One thing that LLMs are very good at is naming variables and functional names. there is one thing which works poorly in cursor still when I'm using this way of editing code. It's important I don't edit it manually because it messes it up so much. The AI thinks it's working in old version of the code, so it's just a little bit confusing here. Okay, let's accept this, but going on? Okay, it wants to run the test command. Okay, it says that there is a failing test. We don't care. The thing is, we have two tests. One of them is passing. This is all that matters. Okay, I will edit this manually because explaining this to the model will be counterproductive. Okay, setting exited to false here is a bad idea. I think instead we should have a wrapper for the execute function. Okay, so we will do this here. Okay, so we are passing this by copy. That's fine. Okay, this is actually nice.
says, "Hello, ma'am. This is a reminder that TTS only works in English. Please use English in chat. Thank you."
Yep, pretty much. There is one more thing which we should validate, and this is the current instruction. Cool. The test cases now are much cleaner. Okay, we can also verify this exit point. Type of this exit point. It's a code type. Very strange type name. Should probably rename this. Okay, so when we start execution, we will clean those variables. Actually, we should probably clean them when we start also.
Travestet says,
Hi, how's it going today?
Hey. All right. We haven't moved much since last week, but... or maybe we are moving. Who knows? We are using AI more today. Oh yeah, I guess I cannot compare. Probably weak pointers. Exactly. No, this is not the way to fix it.
Okay, nice. Do you always play the same tracks as the background music?
I used to have big issues with copyright on YouTube. I used to use a very large library of copyright-free music. The thing is, even though the music was copyright-free, let me find it. Okay, I don't have it anymore. Even though the music was copyright-free, there are still people who are spamming YouTube with fake copyright claims. So even though it was all kind of public domain or Creative Commons, I would still get copyright warnings. And they would just take videos down, they would send me alerts. I was actually close to getting my Google account taken down completely, so I had to switch. And yeah, I switched entirely to AI-generated music. The issue with AI-generated music is that even though it's AI-generated, it still takes time to generate decent tracks. So I have just a couple of them. The ones that you can see on the website are pretty much in the music section. Those are pretty much the only ones that we have. Okay, this is bad. It's not how you do it. So this is how we compare
I see. I totally understand then. Stupid YouTube things.
Yeah. Interestingly, the safest way apparently to have music on YouTube is not to use copyright-free music, but to use music from games. Because games, they are being made by game studios and they want people to play their games online. So they are registering in YouTube and saying that, hey, this is our music, this is game music, and videos with this music are fine. So even though this is copyrighted, this is proprietary music, this is totally fine to use on YouTube. It creates less issues than Creative Commons.
Knight says,
Hey, everyone.
Hey. Okay, I think I will have to break this into two separate functions. One that should verify that the code is still running, and another should verify that it finished with some specific values. Anyway. You've seen in comments that the composer had issues working for us now. It kept trying to revert to this state with an extra test case. Okay, state regs R15 is huge. Actually, a lot of them are wrong. Okay, I think I see the issue. Means that currently the way we do this is that we start a thread which actually... What is this thread? Here. Yeah. So the thread we are starting, this one, just goes here and stops. At this point, we should probably... So maybe after the first stop, we should set the values of all of the registers. That would make sense. So let's go to our control thread. Okay, so we are starting this thread. We are calling sys, saying that worker is running. I want to see the sequence of actions. And the first thing that happens is we are coming here. So this is the place where we should configure the initial registers. set a variable called Okay, at this point we can call getStateRegs. Or maybe getStateState. Actually, let me make a private function that will do this. Point here is to be platform agnostic. So I'm hiding ptrace and user extract. Those are Linux specific things inside another interface, which essentially does the same. This should only be executed on the control thread, exactly. This is our notification. Okay, I'm literally setting everything to 0 here. And then calling setrex. And I don't think I need to set initial registers really. I also don't need to do that. Okay, that should help with the test case. Cool, but you can see that the model, it doesn't really understand the code too well. I think maybe if I switched to a different model, okay, I will open a new composer actually, because this one was tainted by me editing it. In this initial verification, we can probably do it in the setup function. Okay, so I think what happened right now is that we started the speed trace controller so this. It executed control thread, so it's starting to set up, but before anything else happens, we are calling a getState and sending signal PID, this kill PID to the thread which is not yet ready to receive signals. Yep. So the good news is that if PID is 0, then we don't really need to send kill signal there. Let's create a small function. Oops. Actually, this PID, because PID is used across thread boundaries. I think we should make it atomic. This I will keep. Okay, so we are sending a command to wake control thread here. Okay, it's nice. Now let's take care of this atomic PID thingy. Initial getRegs failed. So if what happens is we are calling getState from the test thread, we are putting this command on the command queue, and as the control thread executes, so this is the moment we are taking commands from the control thread. The PID should be set. So this is a concurrency issue. I'm not sure if we will be able to reproduce it now. Yeah. Okay, here's what I think. In the initial setup of ptrace machine controller, this control thread, I think here
Deep fried Kool-Aid chicken just followed on Twitch.
Oh, thanks for the follow.
Deep fried Kool-Aid chicken just followed on Twitch.
Yeah, I think we should initialize this properly. I'm not going to construct a lot of those ptrace machine controllers, so I think the constructor, it's fine if it's not like super fast.
Deep fried Kool-Aid chicken says,
Is it worth going to school for this?
Yeah, I would say so. It's a very fun thing to do, rewarding both by intrinsically and also pays well.
Or should I just look stuff up on YouTube?
YouTube isn't as good. There are some things that are totally skipped on YouTube. But at school you will be kind of forced to go through them. So normally very few people will have motivation to look at some areas of computer science. Like, there is this whole field of logic programming, which is still being taught at school. It's still very popular, but online, like, nobody's talking about this. This exists. There are just some things which exist only in scientific papers and at schools, because this is where they are taught. on YouTube you will probably not find any video that would tell you how to write, for example, like a predicate derivation system, like an expert system that actually can reason using rules of logic, because it's not fun. There are very few YouTube videos that show you how to do any sort of data analysis, right? There is virtually zero data analytics on YouTube, and if you actually want to program anything, that's just so... It's a very important skill to have. Okay, so I have this variable called worker setup that I will just wait here in the constructor. Another attempt. So we have waiting in wait PID, worker thread started, signal delivery, yep. Here. Input output error. I think I should get the original registers also. Okay, so instead of setting all of the registers to whatever value, we will only set those listed here. Everything else will keep their initial value. Still input-output error. Let's check the manual. So we need to fill the data argument, which is the last one. This is what we are doing, I think. Yep. Oh, I see the issue. So here we have to do the reading and writing ourselves. Okay, I'll do a short break. Be right back. So we are reading the current registers, we are altering some of them, and then writing them back. Now this should not produce any more input-output errors. Cool. There is one more bit of our code that I would like to change. It's this one. But okay, let's create a test case with two instructions. Okay. So here are our instructions. Those are two completely separate instructions. First we'll execute the first one. And this is the expected exit code. We could actually execute it from the second. Okay, we should check the AX, of course. That was AI that introduced this bug. Cool. Now let's make another test case with two instructions, but now they will be linked together. So this gives us a shared pointer, and that instruction So we cannot combine them together because they don't have locations attached. We also need to create locations for them. Okay, locations are also shared pointers. I will replace this. And there is this insert here. That we could play with. What does it do? Okay, it's actually very good. It's kind of what we need, but we need to make a copy. We'll disable this test, make sure that everything still works. Okay, assertion root failed. Why are we calling this root widget? I see, we have this widget for object. I see. We don't need this list of locations anymore. And this create empty returns reference. So nice. Why is this failing again? We are now creating a proper root widget. Oh, I see. There is no window there. I think we'll have to change this API. Or maybe not. Maybe you can change this widget for object. I think the key issue is in this function, because when we want to relocate an object to some location, it's not given that this object has a widget. So we need some kind of function that doesn't necessarily give us a widget. No. I think there may be quite a bit of code that depends on current semantics. So maybe let's skip this. And I think this should be the default. We touched location, so it forces rebuild of almost everything. Okay. Okay, the two tests are now passing. And now, when we execute instruction 1, we should finish at instruction 2. this, I would like to create a function for doing this. It's not super efficient, but it's readable. Now we should have 3 tests, and hopefully all of them will pass. Unfortunately, AI is not super... It wasn't super usable, it was breaking the code, but I will get back to using AI in a moment. So 2 separate instructions now failed. Oh yeah, we are starting with instruction 2 here. That should be RBX. There's no way of passing right now. State array x contains 42. How is this possible? This is bizarre. Let's print the machine code, because maybe this will explain the issue. Okay, so here we have our code.
Nadarkim says,
Sup, Math? How are you?
Hey, good. We're slowly getting the debugger in shape.
In fine too.
Okay, I wanted to print this machine code. Okay, here we are updating the... Actually, don't know what. Oh no, this is just execute. Update code is what we want. Okay, so this is the machine code that we have. Let's load some disassembler. Okay, looks perfect actually. Into array X we are moving this value, into RBX we are moving this value. I assume this is 1337 and this is 42. And then we interrupt. Super simple code, right? Okay, we are calling regular getRegs, and getRegs should just copy the values of registers here. So I think this is the initial checking of the state. Maybe not. So we call update code. This is where we construct the new code, and after we are done, we do this. So this is where we are sending the CUSR, swapping the code, we are starting the execution, and then we have received trap. And this is probably when we are reading the final registers. Okay, and it passed now, okay. Strange. Let's run this a couple times. Seems to be working now. I think every time we enqueue something, we should put a log statement. Cool. Nice. So we can now see, we can actually see the test cases as they are executed. There is not too many logs now. I think it's a good time to take another look at the decomposer mode. Let's open a new composer. Oops, I don't know, what was that? And let's switch this to a decent model like O3me. This one is a thinking model, so it actually has some kind of thinking tokens before it does any edit. So what do I want? Yeah, I would like to test a case where I have a jump instruction. It's thinking, so no worries. Those three dots here, they mean that it's generating some internal tokens. It's not showing them to us because this is proprietary secret of OpenAI. Okay, I guess this is the way to do it. Yeah, actually that should work. Yeah, it says, hey, I ran the test and it passed, but it didn't pass. It was not executed. Okay, what is it doing again? Okay, this is just crazy. It pretends that it's running the test. It even says XX in place of milliseconds. Okay, this was nice. So now I would switch model to Cloud Sonnet. Yep. Let's ask it to So O3 Mini, it fought a lot, but in the end, it was just bad. Okay, so here is our new function, should be similar to this one. Basically the same, the difference is just how we initialize instruction. Yep, we can accept everything. Cool. It's nice, I could almost tell it what to do using natural language, almost. Okay, where is the make instruction? I don't see it. Oh yeah, here it is. A reference, I guess that's fine. Okay, so we have covered most of the cases that we will actually need in Automat. One thing we still want to have is test case for get status during a loop. And this is harder. Harder job is usually better in O3 Mini. So let's try this. I actually wonder what is in the stream of FOT tokens of this model, because those are usually quite interesting to observe. Okay, let's try to do manual copy-paste. Okay, so here is an instruction that sets a register to some value. Okay, this is not what we want. We can actually do next instance. That will work. What's the issue here? Oh yeah, it forgot a star. Okay, I think this infinite loop could work. If we're lucky. I think the destructor may cause some issues. We'll see. Yeah. It did finish correctly. So what happens when we destroy the ptrace controller? We just send kill signal. And yeah, this one executed for exactly 100 milliseconds. can make it faster. Let's do it. Let's make it 10. 10 is plenty of time. Cool. What's interesting is that when we run those test cases, we are actually creating tons of processes. So it is probably messing up my OS PID numbers. They're probably in like thousands now, hundreds of thousands. Okay, so this O3 Mini, it's not that great. Let's try GPT-4o maybe. Okay, let's not complicate this too much for now. This is weird. It's okay, we can accept it, but it should be verified using verify state. Actually, we don't need a separate test case because just putting, I will reject this and also skip this, cancel this. Yep, this simple verify state, I think it will fail or it will lock up because the thread is still running when we call this. It says no such process. This process exists, but it's running. It's not in the stopped state. I'll be right back.
streaming chair. No streamer here. Let's do anarchy.
Okay, we are saying reading registers. So at this point, I think what happened is we sent a SIG user to the, let's enable printing of stuff that's happening. Blah blah blah. Okay. So we are starting execution. Entering wait PID. Okay. So the control thread got attached to the worker thread. It entered PID because actually I don't know why. Yeah. Because worker is running, right? So we are entering wait PID. But then it was woken up by SIG user 1. So we are getting these reading registers. Let me see what happens if we get SIG user 1. Okay, when we get SIG user 1, we are just ignoring it immediately. We are just saying, okay, we got a signal, we are waking up, but the child can now continue. But I think what we could do here is that already take some of the tasks from the worker this work command queue and execute them.
Marek Kowalski says,
When Sigisrone is called, Automat should play song with Sigisrone title.
Yeah, that's a good point. This one, right? So when assigning signals to those songs, I actually tried to make it to kind of match the vibe of a signal, if something like this could even be said.
exactly?
Yep, pretty much. So theoretically, each command should be able to deal with worker stopped, true or false. Okay, now this should work. Okay, so this is a failure because we are not in the get state. So in these get regs we are also reading RIP, which we are not passing here. Let's also do RIP. It seems to be at the very end. So those are mostly general purpose registers, like most of them, except the RAX. Anyway, we have RIP and we can assign RIP. Okay, actually I'm not sure about this. Maybe it should not be part. Of this struct. I was wondering whether to make it a reference or a pointer. I think reference makes more sense. It forces me to think about this. Okay, and here we will do something else, which is cool, exactly. So here, right after we get the registers, I think we could resume. Just to increase the speed of this. Should we make it an error if the worker is running and we call resume worker? I think so, yes. Yeah, because the code shouldn't resume this multiple times, it could cause some weird side effects if we resume accidentally. So this should be made an error. We don't need this error. So we had this bit of code which did resume worker. 3, not this, and get state.
Madarkimp says,
Well, I have to go. Bye.
Yep.
See you soon.
See you around. I actually wonder, I don't think it's really possible to stop the worker immediately like that. When we send a signal, we don't have to wait on another syscall. It's tricky. It's tricky to do this. Anyway. So if we couldn't get this state, then I think we should reset it. Or actually no. Actually, if we cannot continue, if we cannot resume the worker, we can just log the message and continue, because we got everything we wanted here. So now we can analyze the map. Okay, this is actually good. We can even reset it by default. Simple, right? Actually, it's not entirely thread safe. And there is an issue here, so when we get this resume worker, Still failing. Weird. Oops. Okay, that was decent. So we're starting execution, waiting in wait PID, reading the state. Somehow getting this state fails. Okay, none of the tests have passed now. It blocked for 100 milliseconds. Did I change something? I think what could be going on? Okay, this sig trap. We should get sig trap. There is CC at the end. It doesn't seem we are getting this callback here. Oh yeah, because it has to be the opposite. If worker is stopped, then we should resume it. Yeah, that was the issue. A new kind of signal, something that we haven't seen. What is signal 11? Seg-V, segmentation fault. Okay, if it's a segmentation fault, then we should keep it stopped. Resuming this would just cause another segmentation fault. Okay, so we accessed memory at 0. I think it would be easier to debug if we run this under debugger. I'm not sure if I can access the worker thread under debugger. Let's see.
Marek Kowalski says,
I'm out of the loop, so pardon my question. Do you spawn subprocesses for assembler widget execution?
Not just execution. While the assembler widget is alive, it has a separate process. This separate process is alive as long as the object is there. Okay, under debugger, very weird things start to happen, so...
So one subprocess per one widget?
Yep. The idea here is that a widget represents a virtual machine, something like a virtual machine that maintains registers and so on. Yep. The thing is that process is only going to execute the assembly when assembly actually calls outside. That process traps, it calls into debugger, and Automat continues because it receives the debugger events. It can continue like following the connection, like where the assembly finished execution. To me, this is concerning that we are blocking in wait PID, but there is no log line that would say what happened. Okay, we could say worker stopped through here. Because those are just different types of worker stop. Okay, we are not receiving those continued signals. This is good. Now we should see more info about what's happening. I'm probably doing something stupid. Okay, now at least it's finishing. This is kind of random what's happening. That worries me a little. Fascinating. 6xv while accessing memory. This is 1337, I think. Yeah, so this is the value of the LAX register. Okay, I see. It's getting the state. Yeah, it should not resume. That was a bad idea to resume the program immediately. Okay, now some tests worked, some tests failed. Okay, the infinite loop fails. How does it fail? It fails after 10 milliseconds, which is good. So we created some new code. This is the infinite loop code. We can actually debug this, disassemble this, I mean. Yeah, so it executes this instruction and then jumps back. Okay, worker is running. This is good. This is the issue. Apparently, current instruction is wrong. Let's print the map, the instruction map. Oh, and I need to call this actually during get state. We don't want to format this as pointers. Let's do this as numbers, as decimal numbers. I see the issue. So when we are doing this interruption, we are actually at the jump, and the jump is kind of implicit for us. We've inserted this just so that the move can connect to itself. Let's take a look at this in this assembler. Yeah, so we are here. And it says that, hey, this is the next thingy. It's actually not, this is the next in this case. And this segment of code is actually not part of the code map, so we should add it. This is good. This is another bug in our code generation. Okay, so here we are trying to find the next instruction. If we find it and we decide that, hey, this instruction actually was already serialized, so this is a tiny loop, then we are emitting a jump, but this jump that we are emitting here, it needs to be marked as an exit point. The next instruction for, this is the only place where we have emit jump. I know it says jump, but this should really be marked as next. Cool, cool. So the test passed. Nice. So this breakpoint here is unnecessary, we could skip it. We could make this smaller. It takes 5 bytes, it could take just 2. Have a lookup table for this. Anyway. Okay, let's see the other test case, which is failing. This passed. 2 separate instructions, this one failed. There's probably a way to do this properly. Okay, actually, instead of doing this owner before, magic. Let's also say expected. Oh yeah, that's a good point. After we finish executing the So I think the current instruction here is going to point to instruction 1, I don't know. Here, the issue happens here. Yeah, so after we called the trap, instruction 1 executed, it moved to the trap, it stopped, but the trap instruction was finished, so the instruction pointer points to the next one, which is instruction 2. And I think we should fix this. Let's look at what control thread is doing. When a trap happens. this. Okay, now that this was executed, could probably say set this to 0 and call setrex. Maybe not quite setrex. It is actually not such a bad state because the program is paused, so this kind of failure is actually not bad. And all of the tests passed. Nice. We can do the hard one now. The hard one is hot swapping the code which is currently executing. Okay, the way we will do it is first we create a simple instruction that will execute in a loop. That's fine. That's great. We create an instructions array. we call update code, and we are starting executing it. This should execute forever. We can actually verify all those things, but actually we did verify them before, so there is no point here. But I will change one thing. This. Exactly. This will make the tests easier to kind of navigate. So the code is currently executing, and what we are going to do is we will delete this connection. Can we do this somehow? Okay, it returns a pointer to the connection. Okay. Now, this connection, we have to delete it, break it somehow. We need to have a code for deleting connections, right? We absolutely have to. Okay, connection has a destructor, so maybe we can just do that. Oh yeah, it's just manually managed. Okay, so this will execute in a loop, and then we call this hot reloading method, which is supposed to pause the execution, replace the code, but keeping the instruction pointer in place, and then resume execution and follow the next connection. Yeah, this one is going to be fun. Okay, it worked right out of the box, but this is probably an accident. Let's see what happens when we do code update. So we populate the new code. This replacement is interesting. Okay, here I think we can assert that worker is stopped. We can play with it. We do code remapping, clearing, hopping. Okay, we don't fix the instruction pointer at all. Okay, now we should try to find the current instruction. Actually, this is exactly what get state should do. This. Actually, this pair, it occurs in many places. So inside state, we also have something similar in here, the exit point. Actually, this is an error. We should log this regardless of debug settings. So one more place. Okay. Yep. It is important that weak pointer has to be copied out during exit callback. Okay, this should still work. Cool. Okay, what I actually wanted to do was to create a function that will take an RIP and convert it to code point. Actually, this is interesting because if we receive trap, then we are after an exit point. Okay, we can get rid of this condition now. So depending on the situation, we are either interested in those traps in like the position right after instruction or at the beginning of the instruction. Actually, that should be equality here. Should be able to check with equality. It doesn't matter. I didn't change anything, so everything should still work, but now cool. Hopefully that should still work. Nice. Nice. Okay, let's get back to reloading the code. So we have RIP. I think we have to copy the instruction. Yeah, because when I do this, the old instruction is going to be destroyed. Or maybe I don't need to. Okay, so I think now we should go through the new map. So this is some new instruction. code is a string, so we shouldn't use that. Okay, so this is our new instruction pointer. Cool. Yeah. So I think if the new instruction is not found, I think then we should call the exit point. I'm not 100% sure about this, but essentially that. We can log some info to make sure. I just want to be sure that it actually works. Cool. But this test is not very good because, yeah, even if we don't hot patch the code, it will still work. So maybe we can do it like that. So we will first have instruction 2 and then instruction. Maybe should rename them. Actually, this is documented here, so this is how it should exit. However, now that we are running this in a loop, I would like to verify that this works. Hopefully the test should still pass. If it doesn't, then that's good. Okay. I mean, it's even better, because it means the hot patching is probably correct. Because now when I disable hot patching, can disable it like that, and that should cause the test to fail. Nice. Very interesting. So now we didn't patch it, and I suppose some kind of jump which was inserted after instruction 2. Yeah, it was just wrong. I think there is a subtle bug here, because we have jumps that we sometimes insert implicitly. It is a tiny bug, but it's there, it's definitely there. Yeah, this is also a problem. I don't know. Do we need to worry about those issues right now? I think it would be more valuable to we can commit this stuff. Not sure if this works on Windows. Now, I wanted to make a break and then refactor this code a little, but I see it's kind of already 3 p.m. So maybe I will... Let's instead think about next steps. I think this will be more valuable. I think this, we totally did that. Identify the exit point. I think this is somewhat complete. We can now identify the exit point. That's true. Mark this as done. What a beautiful name. P-Trace Machine Code Controller. It reminds me of Java. Yeah, I think this is the next thing we will do. Those things, I think this is also important, lots of important things, but I want to connect it to the UI so that we can actually play with this interactively. For instance, when a connection is broken, I think it would be nice if we automatically reloaded the assembly, so we'll have to address all of those edge cases here, like this or this. There will be an issue on Windows, I'm afraid. So even if we don't want to make this run on Windows, like right away, at least make it compile on Windows is important. So I think I will take care of this offline, maybe tomorrow. maybe of those two things. And on Wednesday, we will come back to the widget, so that, because we actually want to run this in Automat, and I think having tiny bugs, it's not such a big issue as long as we keep track of them. I just want to see it work, so that's the plan. And that's it for today as well. So, see you on Wednesday. Bye bye.